Hello, Algebra 2 students. Today we're going to look at some function vocabulary, and we might talk a little bit about how that would apply in that yogurt video. Let's think for a minute about the video that you watched. What did you see? We saw people going in and buying yogurt, frozen yogurt, and putting toppings on. And how did they determine the price? They determine the price by the weight. So you put your yogurt in your little bowl or your cone, and then you put your toppings on, and you go to the front register, and they put it on the little scale, and then you pay for your frozen yogurt by the weight. So we would have the number of ounces and the cost, right, would be our two variables. So we're going to look at some function vocabulary that we're going to use all year through Algebra 2. Some of it will probably, most of it should be familiar. But we're going to use it a lot as we go through Algebra 2. So let's look at some function vocabulary. You have this presentation on your Schoology page. And when you open it, it'll have you make a copy. So if you want to write in it, if you want to add notes, if you want to put a text box and add notes, if you want to put images, however you want to do it, that's your copy. Okay, so function vocabulary. The first one is relation. This word refers to any set of numbers. We're going to talk about what is a function and what's not a function, right? We talked about that with where do you stand, what's a function, what's not a function. Every input has only one output. That's a function, right? A relation is any set of numbers. Your inputs can have as many outputs as they want. Any set of numbers can be represented by points, by a graph, by an equation. Any set of x and y values, any set of numbers is a relation. Okay, like we talked about in where do you stand, if each input only has one output, that's function. Okay, so the definitions here, one says a set of ordered pairs in which element of the domain, or x value, or input, those all mean the same thing, corresponds to exactly one element of the range. So each input has one output, each x has one y, each domain has only one range. Okay. This is also input. Okay, corresponds to exactly one element of the range. That's output. Okay. So let's think about your video. What was the input? What was the output? How do they determine how much to charge you for your yogurt? They do that by the number of ounces, right? So what happens as the number of ounces goes up, the price goes up, right? So what's the input? The input would be the number of ounces. The output would be the price or the cost. Let's change that. I don't like price. I like cost better. Okay. So if each number of ounces has only one cost, then that's a function. Do you think our frozen yogurt situation represented a function? Would 1 ounce of frozen yogurt ever cost you more than one price? Okay. All right, let's keep going. The range. The range is the y coordinates interrelation. It's the dependent variable. We've talked about another word for range is the output. Okay, in our frozen yogurt video, the output was the cost. Okay, it's the dependent variable, it's the y values. The domain is the next word. What did we do? There we go. Is the set of all x coordinates, or we said another word for that was input, right? So if you're going to the store and you're buying frozen yogurt, your input is what did you decide? You decided the number of ounces, right? Number of ounces of frozen yogurt. That's the domain. Domain is all the x values. So some of the questions you will encounter this year talk about what is a reasonable domain for this function. Okay, what is a reasonable domain? So a reasonable domain would be, how many ounces could we have? Can we use fractions or whole numbers? Could we have 1.5 ounces or 1.2 ounces or 1.3 ounces? Sure. What kind of numbers can we not use for the number of ounces of frozen yogurt? Can we have -3? No. No negative numbers to describe ounces, right? So a reasonable domain would be x greater than or equal to 0. We'll go more into this. Right now, more just a general overview of this vocabulary. What is the domain? The domain is all the x coordinates, the x values, the inputs. All right, we're going to talk about data this year, and we're going to describe it as continuous or discrete. Discrete is if it's individual points and the points are not connected. Now, you might see this in a graph. It might look all over the place. Or it might be in a pattern like a line or the shape of a U, which we're going to call a parabola. Discrete data just means that the points are not connected. Discrete data is used to describe things like cars, people, desk, anything that can be only whole numbers. Continuous is something that can be described in fractions and decimals like weight, cost, speed, time, distance, okay? Individual points, not if they're not connected, that's discrete. So if you're graphing the number of cars, you're graphing the number of people, you're not going to connect the points. Because you can't have 1.5 cars. You can't have 1 3/4 people. No 3.2 cars, no 4.6 people, right? Discrete is something that can only be described with whole numbers. Continuous, this graph is going to show a line or a smooth curve because your points can be connected. You cannot count the number of points because everything is connected. This would describe things like time, height, weight, speed, distance, temperature, anything that can be described with fractions or decimals. Perfectly reasonable to have 1.3 feet or 1.2 yards or 2.6 meters, right? I can be 5.2 inches tall or 5'3". I wish I was 5'3", not quite. Anything can be described with fractions or decimals is continuous. If you're graphing that, you would connect it because you can include the fractions and decimals. Okay. Increasing is another word we're going to talk about this year. What does increasing mean? If something increases, it goes up. In an increasing function, both the x and the y values increase. It's parts of the graph where the function goes up from left to right. Let me show you. You might have, let's do this. So you might have a graph that looks like this. That's increasing, right? And you might have a graph that looks like this. That's decreasing. And you might have a graph that looks like this. The different parts of that graph are called intervals. This interval is increasing. If we look from left to right, it's going up. This interval is increasing. This interval is increasing. Those are going up. This one too, right? What about these other intervals? What are they doing? Decrease, decrease, decrease. Okay, so you can have more than one interval in a function. Part of it might be increasing, part of it might be decreasing. Increasing means as the x values go up, the y values go up. Decreasing means as the x values go up, or as we move from left to right, as the x values increase, the y values decrease. All right. So we've done increasing, we've done decreasing. An ordered pair, it's a representation of the xy coordinate. It's in parentheses, and these are in alphabetical order. So usually it's XY. It might be RS, it might be MN, it might be AB. An ordered pair is a representation of the X and Y coordinate. It's in parentheses, and it's in alphabetical order. X-intercept is where a function crosses the x-axis. Okay, did you know that where you have your x-intercept, the y value is always 0? And the y-intercept, the x value is always 0. So you can find it from the table, you can find it from the graph, you can find it from the equation by plugging in a 0. We'll talk about that later. So much we're going to talk about later. All right, we've done all these. That seemed to go very quickly. All right, we were going to talk about how this relates to your frozen yogurt. So let's just do this. You might want to write these down somewhere. This might show up in a Schoology discussion or quiz or something somewhere. So, not anything you have to submit, but if you want to write them down on a piece of paper or type it in. So let's think about frozen yogurt. We already said that the input, what's another word for input? That's domain. That's x value. That's independent variable. The input is the number of ounces. Do you know that was a number sign before it was a hashtag? Okay. Now, what about our output? Our output is called the range. It's the y value and the dependent. That, in this case, is going to be the cost. So what do you think about this frozen yogurt function? If we're drawing a graph with the number of ounces, so this would be our number of ounces, and this would be our cost. Is this going to be an increasing or decreasing function? What do you think? As the number of ounces increases, as we move from left to right on this graph, as the x values increase, what happens to your cost? The more ounces you have, it goes up. Okay. Okay, so this is an increasing function. Is it a function? Does each input have only one output? If I have 2 ounces, it's only going to have one cost, right? I'm not going to charge this person so one price for 2 ounces, this person another price for 2 ounces. 2 ounces is going to have one cost. It is a function. It is increasing because as the x values increase, the y values increase. What are other words? Domain we talked about, range we talked about. X-intercept, y-intercept, we'll talk about, I won't say we'll talk about that later. X-intercept and y-intercept. The x-intercept is where the y is 0. So when would it cost 0? When you have 0 ounces, you have 0 cost, right? So your x-intercept could be 0, your y-intercept could be 0. In that video, it showed that there was a regular bowl and a dipped waffle bowl, right? Okay, I'm going to take all that away. So let's think about x-intercept and y-intercept. Okay, we said that this was ounces, and this is cost. Okay. In that video, I believe the cost for a regular bowl was 50 cents, and for the dipped waffle bowl was 60 cents, right? So if I chose a regular bowl, at 0 ounces, just the bowl is going to cost 50 cents, right? What if we make this $1, $2? So I'm going up, every line is 50 cents. $3. Okay, so this is 50 cents, right? And then the yogurt with toppings was 40 cents an ounce. Tested my memory here. And without toppings, it's 30 cents per ounce. So what do we want? I think we need toppings, right? 40 cents an ounce. So at 1 ounce, this is 50 plus 40 is going to be 90. It doesn't like me to make little dots there. There we go. This is 1. At 2 ounces, we're going to add 40 more cents, so that'd be $1.30, and so on. 3 ounces, add 40 more cents. Okay. Do you see this is going to be increasing, right? Would we connect these? Is it discrete or continuous? Can we have 1.5 ounces or 1.2 ounces, 1.3 ounces? Sure. So it's continuous, increasing. We talked about the y-intercept here would be 50 cents. What if we change it to dipped? Then the y-intercept would be 60 cents. The y-intercept is where the x is 0. X-intercept is where the y is 0. What else can we talk about with frozen yogurt and math? The domain is the number of ounces. The range is the cost. The cost depends on the number of ounces. Okay, we've talked about it is a function. It's increasing. It's continuous because we can use fractions or decimals. We talked about the x-intercept and the y-intercept. Very good. All right. Have a wonderful day. I'll talk to you later.